So what we're going to look at here is we're going to look at solving equations that involve a combination of the two things that we've already looked at. So what do we mean by that? Well, what we're going to do is we are simply just going to combine the skills that we've already done. So we're going to look at solving equations that involve addition and subtraction, and we're going to look at solving equations that have a bit of multiplication in them. So, for example, if we were to take the equation 2x plus 1 equals 5, we've combined little bits of it. Okay, so in the first set we would have only had something like x plus 1 equals 5, and in the second one we would only have had something like 2x equals 5. So we've brought them together. So all we're going to do is we're just going to work our way through them. And so ultimately we want to be able to solve this so that we get the letter bit on its own, and we're just going to gradually unpack it to get to that point. Okay, so all we're going to do in order to combine them is, rather than doing it in two different places, we're just going to do it in one big column. We're just going to feel like we're adding in an extra step. So in order to get the letter bit on its own, the first thing I'm going to do is get rid of the extra number bit that appears on the left hand side. If I wanted just the letter bit on its own, I would keep the 2x, and I'm going to get rid of the plus 1 bit that's there. So we're thinking about the inverse. If plus 1 was the opposite of adding 1, subtracting 1. Okay, so I need to subtract 1 from the left hand side, but because I've done it to the left hand side, I need to do it to the right hand side as well. So subtract 1 from there. Okay, so that's going to give me 2x equals 4. And what we want to do after that is reduce it down so that we've only got x. So I don't want two lots of x, I just want x. And so again, we need to think about what the inverse is. What's the opposite of 2 times x? Well, we're going to divide. So we're going to divide that by 2. And as a result, we need to divide the other side by 2, which means we get an answer here of x equals 2. Okay, and as a check, we can put that number back into the thing that we started with and make sure that it works. So 2 lots of 2 is 4, plus 1 equals 5, and that's what it said it should give us. So it's looking alright so far. So let's try another couple. 2x plus 1 equals 9. So again, I want to reduce it down to the letter bit on its own. And so I'm going to find the inverse of the number bit that appears, which is the opposite of adding 1. I'm going to subtract 1. So I need to subtract 1 from that side, and as a result, I need to do it from the other side. And that leaves me then with 2x equals 8. I need to undo my multiplying by 2, so it's the opposite of multiplying by 2. I need to divide by 2, so I divide that side by 2, and that gives me x equals 4 as my answer there. Trying the second one here, I've got 3x plus 4 equals 19. So again, I'm going to get the letter bit on its own, so I need to get rid of the numbery bit first. So the opposite of adding 4 is subtracting 4, and so I need to subtract 4 from both sides. That's going to give me 3x equals 15. I don't want 3 lots of x, I just ultimately need x, so I'm going to divide by 3, and then I need to divide the other side by 3. So that gives me x equals 5. What I might want to do here is I've got 10x minus 8 equals 72. And so again, I'm going to look for the inverse of this minus 8 bit. I want a letter bit on its own. So it's the opposite of subtracting 8. I need to add 8. So I'm going to add 8 on to both sides. That leaves me 10x equals 80. So I need to divide both sides by 10. And so x is just equal to 8.